Aim 1 is determining the colonization pattern of Bifidobacterium longum in healthy and tumor-bearing conditions. We chose to work with Bifidobacterium longum because various studies have shown the strong immunomodulatory effect it has on the host. It is shown to improve anti-polio immune response in infants and improve immune system function in elderly. It has also a role in dampening immune responses by promoting T regulatory cells. A recent paper reported that Bifidobacterium promotes anti-tumor immunity, which is comparable to the anti-PD-L1 immunotherapy, and when these two are administered together, it enhances the anti-tumor immunity. Here, you see they have quantified IFN gamma, which is a cytokine, and CD8 plus T cells. So when they fed the mice with only Bifidobacterium, it's a mixture of Bifidobacterium, and when they only administered anti-PD-L1 immunotherapy, the effect is comparable, and when they combine these two, the effect is significantly higher. Another study reported that when mice is fed with Bifidobacterium brevi, the bacteria translocates from the gastrointestinal tract to the tumor region. They tracked the bacteria using bioluminescent protein. As you can see in the graph, the amount of B. brevi in the tumor is significantly higher than when compared to other organs, and they tracked it until up to day 14. Our hypothesis is that B. longum, when administered to tumor-bearing mice, translocates to the tumor site and elicits an anti-tumor immune response. This is a scheme that represents our hypothesis. This is a wild-type gut, and this is gut of a tumor-bearing mice. Our tumor model is the colorectal cancer. It is to simplify our system. The green is the tumor and blue is the bacteria. To prove our hypothesis, we'll work mainly on three objectives. First one is determine the translocation and retention pattern of B. longum. Second is to test the ability of live versus heat-kill B. longum to produce IFN gamma. IFN gamma is associated with gut barrier loss and increase in epithelial permeability, and is shown to produce that and is shown in previous study to be essential for translocation of bacteria. Lastly, we will investigate if B. longum administration produces a positive effect on the tumor in terms of its size. To test if B. longum translocates from normal tissue to the gut to the tumor, we'll use 5 to 6 week old female mice. They will be divided into three groups. One group is fed with live B. longum, another with heat kill B. longum, and third will be the control, which is fed saline. The B. longum is transformed with plasmid containing bioluminescent reporter protein prior to feeding. Colorectal tumor is induced by oral gavage. Oral gavage is injecting the tumor suspension from behind the incisor of the mice. After tumor engraftment, the growth and colonization of bacteria are monitored by tracking the luminescence. We will look at the immune cell recruitment in the tumor, IFN gamma production, and also peripheral blood mononuclear cells. This will determine if the response is local or systemic. At the end point, that is 3 weeks after tumor engraftment, we'll excise the tumor and measure its size. From our experiments, we expect to find if B. longum is involved in immune modulation in tumor-bearing condition, and if this involvement is local or systemic effect. We would also know if live bacteria is required to elicit this immune response. As I mentioned earlier, all previous studies were done with mixture of Bifidobacterium. If in our experiments B. longum alone does not translocate to the tumor site and produce immune response, we will use a mixture of B. longum and B. brevi, as B. brevi is already shown to translocate to the tumor cells. In the reviewers comment for AIM-1, there was concern regarding single cell tracking. I would like to stress that we do not want to track single cells. We want to know where they colonize after the administration. A single bacterial colony has millions of cells, hence we can easily track them using the bioluminescence.